Good morning, ladies and gentlemen. If you hear weird noises in the background while we're doing our video, they are sword fighting out in the little common area outside my room, which is kind of entertaining. All right, we are going to do 4-6B today. We're going to do more work with our complex numbers. All right, so as we move on with our complex numbers, our objectives for the day are going to be that we are going to review our complex numbers so far, and then we are going to add the complex conjugate. So we are going to add a complex conjugate. Oops, spelled it wrong. A-T-E. Okay, so there's our complex conjugate. We've actually talked about conjugates before, so we're going to add to our discussion about conjugates today. So if we review, we start off with a review, which is always nice. Remember that we talked about I represents the square root of a -1. We also talked about that I squared is equal to a -1, and I need this information to reduce many of my statements. Okay. I also want to talk about an even root because I think there's been a little bit confusion about that. If I take a square root, if I took a 4th root, if I took a 6th root, those would be even roots, and they would all have two solutions, a plus and a minus. On the other hand, if I had an odd root, that would be like the 3rd root of A, the 5th root of A, the 7th root of A. Those would only have one solution. Okay? All right, so if I have an even root, taking a square root, a 4th root, a 6th root, two solutions, plus or minus. And if I have an odd root, say a 3, a 5, or a 7, I only get one solution. All right, so let's go back and do an example from our previous material just to make sure that we are understanding. So if we have a -1 plus 4i, and I add that to a -9 minus 2i, if you'll remember, the real components are added together, the imaginary components are added together. So I'm going to have a -1 and the -9 working together, and the 4i and the -2i working together, and that's going to simplify to give me a -10 plus 2i. All right, so that's our first example. And it sounds like they're having so much fun having a sword fight. Then if I do another one and I do subtraction, so if I have 3 minus 4i minus 6 plus 2i, you have to remember to distribute that negative. So this is going to be the 3 minus 6, and then I'm going to have a -4i minus 2i. When I simplify that expression, I get a -3 minus 6i. All right, and then the last example that I want to do from our previous information is one of the multiplication. Oops, sorry, I'm going to scribble that out, and I'm going to write 7 plus 2i, and I'm going to multiply that by 3 minus 6i. So remember, the easiest way probably is to do this in a box. You can choose to do the FOIL method if you would like. Either is appropriate. And I'm going to have a 7 and a 2i here, and a 3 minus 6i here. This is 21 minus 42i plus 6i minus 12i squared. Remember that this is going to be a positive 12, so this is going to reduce to 21 plus 12. It's going to be 33, and then I'm going to have a -42 and a +6 to give me a -36i. All right, so those are all problems from your previous discussion on complex numbers. So our new information for today is the complex conjugate. Sorry, I seem to have issues spelling that today. So in the complex conjugate, we've actually already talked about conjugates. So the only thing that's really new is our discussion on the complex conjugate. So let's go back and remember, okay, E-M-B-E-R. So if I remember, if I have 1 plus radical 2, the conjugate of that was 1 minus radical 2. And the purpose of the conjugate is when I multiply those two things together, the radical goes away. And so for today, when I multiply those two things together, the I is going to go away. So if I show you this process, and 1 minus the radical 2, and I'll put that in a box just so we can see. And I have my 1, my radical 2, my 1, and my minus radical 2. Here's the 1. Then I have a negative radical 2, a positive radical 2, and then I have a negative 2. Because a radical times a radical ends up being what's on the inside, keep the sign. These two terms cancel, and then I would get 1 minus 2, which is a negative 1. So that is the information that we covered previously on conjugates. So now what we want to do, sorry my finger's in the way, so now what we're going to do is add the information for the complex numbers. All right, so if we start with our complex numbers, okay, so if I have a 2 plus 4i, sorry, wait for the camera to focus, there it goes, its conjugate is going to be 2 minus 4i. If I multiply those two together, so the 2 plus 4i multiplied by the 2 minus 4i, I'll put it in a box just because I think it helps us to organize our math. Here's a 2, there's the 4i, here's a 2, and the negative 4i. When I multiply those two together, this is a 4 minus 8i plus 8i minus 16i squared. Remember that I squared is a negative 1, a negative, and a negative. That makes this a positive 16. Forgot the 1. The i's cancel. I get 4 plus 16. This reduces to give you 20. So again, the purpose of the conjugate is to make the I term go away. All right, so if I do one more example, and I give you 3 plus 6i, then if I multiply that by its conjugate, which is 3 minus 6i, and I multiply those two things together, so 3 plus 6i times 3 minus 6i, I'm going to put it in a box. I'm getting good at drawing boxes. So here's a 3, there's the 6i, a 3 minus 6i, this is 9 minus 18i plus 18i minus 36i squared. The two i's cancel. I squared is a negative 1 multiplied by the negative 36. This turns out to be a positive 36. 36 plus 9, this simplifies to be 45. All right, so now we're going to see a different application of a problem that we've actually already done. So I'm going to go back and show you something that we did before. So we had fractions that looked like this, and we talked about I can't leave a radical in the denominator. Because these two are added together, I multiply by the conjugate, which is 1 plus radical 2 and 1 plus radical 2. This piece right here is equal to 1. Okay, and I'm just multiplying by a very specific one to help my math work out. So now I'm going to multiply all of my pieces together. In the top, this becomes 3 plus 3 radical 2. If you'll remember, in the denominator, I'll do this piece off on the side. The conjugate is going to make the radical disappear. So I have 1 minus radical 2, 1 plus radical 2. So this is 1 radical 2 minus radical 2 minus 2. These two terms cancel. 1 minus 2 is a negative 1. So then I have a negative 1 in the denominator. I'm going to divide the negative 1 into each of the terms up top, and I'm going to get a negative 3 minus 3 radical 2. And that would be my answer. So now what I'm going to do is apply that same concept to a complex number. So here's your next example. We've had lots of examples today. I'm going to give you a fraction, 7 plus 5i over 1 minus 4i. Just like with radicals, I can't have an imaginary number in the denominator, so I'm going to multiply by the conjugate of the denominator. Okay, so I'm going to multiply by the conjugate of only the denominator. So I'm going to multiply by the conjugate of the denominator. So now I'm going to have 7 plus 5i over 1 minus 4i, and I'm going to multiply by its conjugate, 1 plus 4i over 1 plus 4i. So now what I'm actually going to do, just for illustration purposes, is I'm going to do my box twice. Okay, so I'll put one of them up here so I can make sure I have enough room. This is going to be the 7 and the 5i, the 1 and the 4i. 7 times 1 is 7. 7 times 4 is 28i. This is 5i, and this is 20i squared. Remember that an I squared is a negative 1. That changes this to a negative 20. So now if I write down the TOPS solution, 7 minus 20 is a negative 13, and 28 plus 5 is a positive 33i. So that's your numerator. So there's the 13 and the 33i. Okay? Now I'm going to manage the denominator, and I'm going to do it in a box again. Okay, so I have 1 plus 4i, 1 minus 4i. 1 times 1 is 1, minus 4i, plus 4i, minus 16i squared. A negative and a negative is a positive, so this becomes a positive 16. 16 plus 1 is 17, and the 2i terms cancel. So now I have a 17 in the denominator. If you'll remember, standard form for a complex number is a plus bi, which means that I need to separate this into two additional fractions. So it's going to be negative 13 over 17 and plus 33i over 17. You have to split this up into two separate fractions, and it has to be written in this manner. And this is going to be your answer to this problem. All right, I will do one more example for you just of the fractions with the complex numbers, and then I'll give you your 3 problems. So actually a fairly short video today, which is nice. Okay, now I'm going to have 5 plus 2i, and I'm going to put that over 3 minus 2i. To be able to simplify this fraction, I have to multiply by the conjugate of just the denominator. Sorry, had to have a little coffee break. Okay, so if I multiply, I'm going to multiply by 3 plus 2i over 3 plus 2i. Okay, I'm just going to put parentheses around these so you understand that everything is multiplied together. So now I'm going to do the numerator over here. Okay, so this is my 5, the 2i, and then I have a 3 and a 2i. If I do that multiplication, this is 15, 10i, 6i, 4i squared. Okay, so this becomes a negative 4. All right. If I add those things together, 15 minus 4 is 11. Okay. And then I have 10 plus 6 is plus 16i. And that's going to become my numerator. Okay, so in the top I'm going to have 11 plus 16i. Okay. Alrighty, so now let's manage the denominator, and I'm going to do it right here. Okay, you have a lot of information to manage, and it's kind of nice if you do it all kind of off to the side, just to help keep all of your math numbers straight. Alright, so now if I do this one, here's a 9, a 6i, a minus 6i, and then a minus 4i squared. Okay, notice that this becomes a positive 4. These two terms cancel, and then 9 plus 4 is going to be 13. So now I add that to my denominator, and then remember that you have to split these up into two separate fractions. So it's going to be 11 over 13 plus 16i over 13, and there's your answer. So that's kind of nice. It looks like you're doing complicated math, but actually it's fairly straightforward. Alright, so now let me give you your 3 problems. I'm going to give you a lesser number of problems today because the problems take a little bit more time. Alright, so your first one is going to be 3 minus 6i over 4 plus 2i. Your second problem is going to be 5 plus 3i over 2 minus 3i. And then your last problem, I'll put it right here, is going to be 6 plus radical 2 over 3 minus radical 3. All right, good luck doing your problems, and then we will go over these in class today, or tomorrow, sorry. Good luck.